All right, let's just dive right in, shall we? I want you to picture the world roughly 250 million years ago. We are talking about a time of absolute extremes, devastating heat and monstrous, terrifying creatures that honestly would make a T-Rex look like it showed up late to the party. In this explainer, we aren't talking about those massive, earth-shaking titans of the Jurassic or the Cretaceous periods. No, we are looking at the ultimate underdog epic, the dawn of the Triassic dinosaurs. This is the incredible, completely improbable story of how a marginalized little group of tiny, fragile reptiles somehow managed to survive one of the most brutal environments in Earth's history and eventually conquer the entire globe.
So, who really ruled the Triassic? Now, I want to ask you this because it might just completely challenge what you thought you knew. Pop culture loves to paint this picture of dinosaurs dominating the Earth from the exact second they evolved. But honestly, that is a total myth. For tens of millions of years during the Triassic period, dinosaurs were not the kings of the castle. Not even close. They were the underdogs, living in the literal and figurative shadows of much larger, far more terrifying rulers. Let's set the scene and actually look at the world they were born into.
Welcome to Pangaea. Over 250 million years ago, all of Earth's landmasses were smashed together into this one massive supercontinent. And it was a harsh, totally unforgiving place. The climate was mostly arid and blistering hot, with absolutely zero polar ice caps. Life here was just a constant, grinding struggle against severe dry seasons, sweeping mega monsoons, and wild temperature swings. It was right here, in this absolute crucible, that the very first dinosaurs had to somehow figure out a way to survive. While the earliest dinosaurs were just barely stepping onto the scene, and we're talking creatures many of which were no bigger than your average golden retriever, the landscape was actually dominated by the true titans of the era. I'm talking about massive synapsids, which were these giant proto-mammals, and pseudosuchians, the heavily armored apex predator ancestors of modern crocodiles. We're talking about absolute beasts reaching 7 meters in length. So next to these giants, the early dinosaurs were really just trying to, not get stepped on or eaten.
To really understand how our underdog protagonists got their start, we have to look at a pretty crucial evolutionary split. Around the early to middle Triassic, the dominant reptiles known as archosaurs, which literally translates to ruling reptiles, divided into two main branches. On one side, you had the crocodile line, the pseudosuchia. They basically took the crown early on and ran with it. On the other side, you had the ornithera, the dinosaur and bird line. This second branch started off remarkably small, producing these diminutive, agile, almost bird-like proto-dinosaurs. They absolutely had to rely on speed and wits rather than brute strength.
Once the dinosaur lineage split off from those archosaur ancestors, they quickly started to diversify. You can track this incredible divergence into two major clades: the ornithischians, which would eventually give us the famous horned and armored plant eaters, and the saurischians, which include the giant long-necked sauropodomorphs and the meat-eating theropods. And hanging out right near the very base of this evolutionary tree are some incredibly fascinating early predators that we're going to focus on today. So, here is the absolutely crucial point. How did these early dinosaurs survive at all against their massive archosaur cousins? Well, when you look closely at these early dinosaur forms, one massive survival trait jumps right out. They are standing on two legs. Bipedalism was a total game changer. By walking and running on their hind legs, they became incredibly fast and super agile. But more importantly, it completely freed up their front limbs. Now they suddenly had hands. Hands for grabbing prey, manipulating objects, and defending themselves against those larger four-legged beasts roaming across Pangaea. To really grasp the sheer diversity of this dawn era, let's juxtapose two of our most famous early protagonists, both of which were discovered in the Ixcualasto Formation down in Argentina. On one side, we have the swift, tiny Eoraptor. This little guy was barely a meter long, weighed just 10 kilograms, so yeah, about the size of a medium dog. But on the other side, we have Herrerasaurus. Now, this was a completely different beast entirely, up to 6 meters long, built like a prehistoric tank, complete with deadly sharp claws and a highly specialized jaw joint for gripping struggling prey. Let's look a little closer at each of them. First up, Eoraptor. Its name brilliantly translates to the dawn thief, and it's a true mystery in the world of paleontology. It was incredibly primitive. For instance, it still had 5 fully developed fingers, whereas later meat eaters famously lost digits over time. And this primitive nature highlights a fascinating scientific debate. For years, scientists have argued over where exactly Eoraptor fits. Was it a basal theropod, like a true meat eater? Or, as recent studies of its teeth suggest, was it an early sauropodomorph? That would actually put it at the very base of the family tree that led to the giant long-necked plant eaters. We aren't taking sides on this debate today, but it just beautifully illustrates how blurred the evolutionary lines were at the dawn of the dinosaur era.
And then we have the enigma that is Herrerasaurus. If Eoraptor was the swift, tiny survivor, Herrerasaurus was basically early evolution's experiment in building a larger, deadlier predator. They lived right alongside those massive pseudosochians we talked about earlier, yet they somehow managed to carve out their own niche. But, just like our friend Eoraptor, its exact classification is hotly debated within the scientific community. See, it has this unique intramandibular joint in its jaw, which is a classic theropod trait, but it also has these really primitive features that make a lot of paleontologists categorize it as a basal saurischian. That means it might actually be a close cousin to true dinosaurs, rather than a direct ancestor. Regardless of what label you slap on it, it absolutely proves early dinosaurs were capable of scaling up. Still, we can't forget the broader picture here. Even with larger outliers like Herrerasaurus running around, most early dinosaurs were fundamentally the underdogs of the shadows. I mean, think about it. How do you survive when the world is quite literally ruled by giant crocodile cousins? Well, you adapt to the spaces they ignore. Evidence suggests that many early dinosaurs occupied nocturnal niches. They were hunting at night while the larger predators slept, or they migrated to higher, cooler latitudes near the poles, places where the cold-blooded competitions simply couldn't function efficiently. The biological toolkit that made that kind of survival possible is an absolute masterclass in adaptation. When we look at bone histology and dental records, we can see exactly how they pulled it off. Elevated growth rates allowed them to mature super rapidly, essentially outpacing droughts and hungry predators. Bipedalism, as we mentioned, gave them unmatched agility. Diverse dental forms meant they were incredibly opportunistic eaters. If meat was scarce, no problem, some lineages shifted rapidly to eating plants. And, crucially, this is a big one, protofeathers provided thermal insulation. This meant that while other reptiles were getting super sluggish in the cool nights or those high-latitude winters, the dinosaurs stayed warm, active, and ready to hunt. But, as we know, the Triassic period didn't end quietly. It went out in an absolute literal apocalypse. Around 233 million years ago, the Carnian pluvial event brought this massive spike in global humidity, which really jump-started early dinosaur diversification. But the real climax? That hit around 201 million years ago. Massive volcanic eruptions physically split the equator, releasing just millions of tons of toxic gases. The atmosphere choked on CO2, the oceans rapidly acidified, and then the sky went dark. Ash completely blocked the sun, triggering a brutal, prolonged volcanic winter that sent global temperatures plummeting way below freezing. And the devastating result of that sudden, apocalyptic deep freeze? 76. That is the percentage of all species on Earth that were completely driven to extinction. To put that into perspective, more than 3/4 of all life was just wiped off the map. Almost all of the dominant, heavily armored pseudosuchians, the absolute rulers of the Triassic we've been talking about, gone. The ecosystems completely collapsed, and the titans of the old world simply couldn't survive the brutal new reality. But here is the incredible twist of this whole explainer. The dinosaurs survived. And get this, they didn't survive because they were bigger or meaner or somehow superior fighters. No, they survived by design. Remember those protofeathers we talked about earlier, the ones meant for cooler nights? Well, they acted as perfect thermal insulation against the freezing volcanic winter. And their malleable growth rates allowed younger dinosaurs to basically just stop growing during the ensuing famines, allowing them to survive on minimal food. The very traits that helped them scrape by as these marginalized underdogs in the cool shadows suddenly became the ultimate survival tools for an apocalyptic ice age. Talk about hitting the evolutionary jackpot.
Which brings us to this really profound quote derived from the research. The rise of the dinosaurs was much more opportunistic rather than driving the incumbent of a niche to extinction. I think this is the absolute ultimate takeaway. Dinosaurs didn't conquer the globe by battling the ruling reptiles to the death in some epic prehistoric war. They conquered it simply by outlasting them. They survived a completely random geologic disaster that essentially cleared the board. And when the dust finally settled and the Jurassic period dawned, the dinosaurs found themselves stepping into a completely empty world, ready to take the throne. So, as we wrap up this journey into the Triassic, I really want to leave you with one final provocative question to chew on. What would the world look like today if that Triassic volcanic winter never actually happened? If those massive crocodilian ancestors hadn't been wiped out by a total geologic fluke, would dinosaurs have ever ruled the Earth for the next 135 million years? Or would they have just remained small, feathered underdogs, forever darting through the shadows? It is absolutely fascinating to think about just how fragile the history of life truly is. Keep questioning, keep learning, and I will catch you in the next explainer.